Hi, today I will be making a smart plant care systems on the Tinkercad. So this smart plant care system is an automated environmental monitoring designed to maintain optimal growing conditions of the indoor plants by integrating a soil moisture sensors to check the hydration levels and a photoresistors to measure light exposure and a temperature sensors to track the ambient heat. If the system removes the guesswork from plant maintenance using an Arduino to process the data, the project can automatically trigger a servo motor to act as water levels when the soil is dry and display real-time health updates on an LCD display, ensuring the plant receive consistent care even when unintended. So this is a component requirements. We need one Arduino Uno, one breadboard, one LCD displays, the I2C version, which is only has 4 pins, and 2 micro servo motors, one soil moisture sensors, one LDR photoresistors, one TMP36 temperature sensors, and piezo buzzers, and one 10 kilo ohm resistors and some jumper wires. For the prototype, we have to first connect the 2 servo motors to the digital pin by connecting the signals from the servo motors to the digital pin of the Arduino Uno. Here the motor that controls the opening of the windows are connecting to the digital pin 3, and the water valve the watering motor is connecting to the digital pin 2. And we also need to connect both the power and grounds to the 5V and the ground for both of the motors. Okay, and next we'll connect the photoresistors like this, and we need to connect the first pin of the photoresistors to 5V. The second pin, which is the terminal 2, connects to an resistors and to the ground, and we have to connect the analog pins from the Arduino Uno to the ground pin side of the photoresistors. Here I'm connecting to A1, and temperature sensors connect both the power and ground first, and next we'll connect the valve, which is the middle pins, to the analog pin also. Here is connecting to A2. The buzzer connects the positive to the digital pin. Here is digital pin 4, and connects the negative to the ground. And here the soil moisture sensors, we only connect the top 3 pins, which is the ground, VCC, and the signals. The VCCs connects to the 5V first. The ground, of course, connects to the ground, and signals connects to the analog pins, which is the A0. For the LCD display, since we are using I2C LCD displays, there's only 4 pins. Connect both the ground and VCC, which is the 5V and ground. The STA connects to the A4 analog pin 4, and the SCL connects to the analog pin 5 on the Arduino Unos. Okay, now for the codings. First includes both the library for the servo motor and the liquid crystal I2C, which is the LCD displays with the I2C board. And first we can include the library by clicking these icons and go to the liquid crystal I2C and click include. Also the servo motors here. So first we'll define 2 objects for the 2 servo motors. One is the water valve servo motors, and one for the windows openings motors. And here we need to define the LCD displays to the correct address for the LCD displays. For here, I'm using the 32 address, So we can see here, so we have to put on the correct address for the LCD displays. I'm putting 32, so this has to be put as 32, and we'll put 16 times 2, which is the layout of the LCD. And here we need to define the soil pin to the A0, the light pin to the analog one, A1, and the temperature pin to the A2. And the buzzer will be defined to digital pin 4, as you can see here. For the setup sections, we need to define the two servo motors to which pins they are connected to. So for the water valve servo motors, it is connected to the pin 2, and the window opening servo motor will connect to the pin 3. And we need to set up the buzzer as output. And we need to set both the motor to 0 degree as default. And we need to set up the LCD displays backlight and initialize the LCD display. Here we will need to define the moisture as analog read from the soil pin. The light value will equals to analog read from the light pin, which is a light sensor pin. And for the temperature calculations, we need to define the voltage value as 4 floating points, and the voltage is equals to analog read from the temperature pins divided by 5 times 1024. And we need to set the temperatures as integer values, and the temperatures degrees Celsius is equals to voltage minus 0.5 divided by 100. And for the water logic, so if the moisture values is below 300, the water valve will be rotated 90 degrees to indicate to simulate the sensors for watering the plant. And the LCD, and on the LCD display, it will print as the watering status is on, or else the water valve will be set to 0 degrees, and the LCD displays will show as off for the watering. So for the window logic, if the light value is below 200, which is very dark, the window will be open automatically for the plant to receive the sun. So first here, if the light values is below 200, the windows will the servo motor for the windows will rotate 180 degrees to indicate to open the windows as 108. And next will the LCD on the LCD displays, the window status will be shown as open, or else the servo motor will be not turning, which is 0, and the LCD displays will show the Windows status as closed, which is here shown as the short form because we need to save space on the LCD displays. So here is the logic for temperature alarming. If the temperature is below 10 degrees, which is too cold, the alarm will be making sounds, or the temperature is over 35 degrees, which is way above the range for the plant. The buzzer will make sound, alarming sounds, and the LCD display will show as the temperature alarm. If no, the buzzer won't be making any sounds. The LCD won't be shows any of the status, and the LCD print will print the the temperature strings and the temperatures Celsius values. And the LCD will print the C, which is for the temperatures values, and the L for the light intensities. And next it will print the light value as well. And next is to delay by 500 milliseconds. Okay. And now we'll start the simulation and see how it works. So if the moisture so if the moisture sensors detects the plant is still wet enough, the watering valve and the motor won't be turning. So if it's too dry, it will turning to indicate that the plants will be watering. And for the photoresistors, if it's too dark, I mean, so if the light is very bright, the motor won't be turning. Okay, so if the environment is too dark, the motor that indicates to open the windows will be turned 180 degrees. Okay, to indicate that the windows have been opened. So for the temperature, if it's below 10 degrees, it will show on the LCD displays that the temperature has a warning level, and the piezo buzzer will make a sound to indicate that the temperature is too low. So if it's over 35, the buzzer will also make a sound to indicate that the temperature is too high for the plant, and it will also show the alarm indicators on the LCD displays. So this is how this smart plant care system works.